Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this problem, we're going to be going over problems 1 to 10 of the Algebra 2 Trig January 2016 New York Regents exam. If you have any questions about any contents of this presentation, just ask your question in the comment section below, and we'll be glad to assist you. All right, let's take a look at number 1. It says a survey is to be conducted in a small upstate village to determine whether or not local residents should fund construction of a skateboard park by raising taxes. Which segment of the population will provide the most unbiased responses? So the word unbiased basically means that you're not leaning in any direction, either for or against, okay? So we're going to represent this with a number line. And then in the center, you have 0, okay? So this is positive, and this is negative. Positive is people who are in favor, okay? So positive is for, I just color code this, positive is for, and negative is against, okay? So if you're against or for a certain event happening, then you are biased in a certain direction. Okay, but if you are not for or against, so it's hard to determine if you're for or against, then you are unbiased. You're basically somewhere in the center, okay? So what are we talking about here? What we have is construction of a skateboard park by doing what? Raising taxes, okay? So these two events can basically polarize people. It can cause them to lean in one direction or the other. So our goal is to look at these options and see which people lean in the direction in favor of the skateboard park or against it because of raising taxes. Okay, now let's take a look at the first one. A club of local skateboard enthusiasts. Do you think that they will be for the construction or against? They're skateboarders, so they will love this so much. So they are for, so they're biased in the positive direction. Okay? So this cannot be an answer. Remember, we're looking for unbiased responses, people who do not have any leanings. Okay? Number 2, senior citizens living on fixed incomes. Now, if it were just senior citizens, it's kind of unbiased, but the component of fixed income creates a problem. If your income is fixed, do you want your taxes raised? Do you want to pay more money for taxes? The answer is no. So senior citizens living on a fixed income are leaning in the negative direction because of the impact of the tax raise on their fixed income. This is a biased response in a negative direction. A group opposed to any increase in taxes. We can clearly see the bias here, opposition to a tax raise. So that is automatically a negative bias, okay? So this is not what we're looking for. Option 4 should be the answer based on elimination. It says every 10th person 18 years of age or older walking down Main Street. Is there any mention here of skateboarding or taxes or anything related to taxes? The answer is no. So this is an excellent choice if you want to get unbiased responses because they do not lean to the left or to the right. Okay, let's take a look at number 2. It says, which angle does not terminate in quadrant 4 when drawing on a unit circle in standard position? Now, one thing you want to keep in mind when you're drawing angles in standard position on a unit circle is that the direction of your rotation impacts the sign of the degree. Okay, so do not forget that when you're rotating in a clockwise direction, your angular measures carry a negative sign. All right, but when you're rotating in a counterclockwise direction, your angular measures carry a positive sign. Okay, so the sign of the angles tells you what direction you want to rotate in. Now, let's look at the first option. Negative 300 degrees. What quadrant is that? Now, if you take a look at this, if you ignored the sign, you would end up in quadrant 4 and you would have fallen into a trap. okay? But since it's negative 300, we're going to rotate in the clockwise direction. Think about down as negative, all right? And then think about up as positive. That's an easy way to think about it. And you, of course, always start from 0 degrees, the positive x-axis. So part of a circle, negative 90. Too small, keep on going, negative 180. Add another 90, actually subtract another 90, negative 270. Keep on going, negative 360 is a coterminal angle with 0. So we need to back up. 300 degrees is going to be somewhere here. Okay, 300 degrees will have a terminal side somewhere there on the unit circle. Okay, so let me draw a circle on there. It's not necessary, but just for the sake of it. So the question now is, what quadrant is this terminal side in? Okay, so if you rotate like this, clockwise, this is negative 300 degrees. This is quadrant number 1. Okay, so this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. The question asks for which one does not terminate in quadrant 4. Angle negative 300 terminates in 1, so our answer is option number 1. Okay, let me just graph the other ones for you to see, even though it's not necessary, just to illustrate, all right? So 280 degrees, you're going to go clockwise, and it's going to be somewhere here. 280 degrees will be somewhere here, because this is going to be positive 270. So this would be 280 degrees, as you can see, is in quadrant 4. Negative 50 is going to be you're going to start from 0. You rotate downwards. Negative 50 will be somewhere here. Negative 50 degrees. Okay, let me show you the direction of rotation. So for 280, we go like this. Now, and then for negative 50, you just rotate like this. You see these two are in quadrant 4, and then 1030. Oh wow. For 1030, you gotta do you gotta carry out multiple rotations, okay? So since it's so big, I don't want to waste time. So I'm gonna say, okay, you know what? I'm gonna keep subtracting 360s from this angular value to find the positive coterminal angle to 1030, okay? So I know that if I rotate twice, I have 720. Subtract that, 0, 1, oh, 310. So 310 and 310 and 1030 are coterminal. Where is 310 degrees? 310 degrees, this is going to be 270, should be somewhere here. So that is 310 degrees, which is the coterminal to 1030 degrees. Quadrant 4 or 3, so we can clearly see our answer is option number 1. All right, let's take a look at number 3. It says the expression 1 over x plus 3 over y over 2 over x y is equivalent to. So you want to remember that whenever you're adding fractions, the denominators must be identical. Okay, so you went over that in middle school, but we're now applying that idea to algebraic scenarios. Okay, so if you look at the numerator, we want to combine these two fractions. So we have two fractions, and then we can multiply the numerator by the reciprocal of the denominator to finish the problem off. Okay, so what can we do here? So in the numerator, the LCD of x and y is xy. So in order for this denominator to be the LCD, I have to multiply by x, top and bottom. And then in order for this denominator to be the LCD, I have to multiply by y, top and bottom. Okay, so that's just because the LCD of x and y is xy. So we want to make the denominators equal to the LCD. Okay, so we have y over xy plus 3x over xy, and that's divided by 2 over xy. Now remember that multiplication commutes, so y times x is the same thing as x times y. Now in the numerator of our complex fraction, the denominator is identical, so we can combine them as y plus 3x over xy divided by 2 over xy. Now we have a quotient of fractions. This is known as a complex fraction. Now, how can we simplify this? You simply drop, change, flip. Okay, you multiply the numerator fraction, algebraic fraction y plus 3x over xy, by the reciprocal of the denominator. Okay, division is the same thing as multiplying by the reciprocal. That's why you drop the top, change your division to a times, and flip the bottom. If you do that, the xy's divide out. And since addition commutes, you can rewrite the numerator as 3x plus y, since x comes first in your alphabet, divided by 2. Answer is option number 4. Okay, let's take a look at number 4. It says, which relation does not represent a function? So remember, a function assigns every input to exactly one output. If you assign one input to more than one output, then you do not have a function, okay? So what you want to remember anytime you're asked about a function or not is that you know, recall that you need to have no x repetitions. Okay, if you have a repetition with the x's, if you have any repetition with the x's, then what is happening is that you are assigning one input to 2 different outputs. Okay, no x repetitions. That's what we're looking for. So if you look at all these, if you can visualize the input and outputs, you can clearly see what the correct answer is. But one surefire way of making sure you get the correct answer is by converting these mapping schematics into coordinates. All right. So let's formulate coordinates. Let's look at option 1. Option 1, 3 goes to 4, ordered pair 3, 4. 5 goes to 4, ordered pair 5, 4. 7 goes to 8, ordered pair 7, 8. Look at your x's. Do you see any repetitions there? The answer is no. So this is a function. That's not what we're looking for. Remember, we're looking for what is not a function. Option 2, 3 goes to 8, ordered pair 3, 8. 5 goes to 4, ordered pair 5, 4. 7 goes to 6, ordered pair 7, 6. Look at your x's. Are there any repetitions? The answer is no. Eliminate that. Option 3, 5 goes to 4, 5, 4. 5 goes to 6, 5, 6. 7 goes to 8, 7, 8. Now look at your x's. Are there any repetitions? Yes, we do have repetition with 5. Okay, so what does this mean? This means that you're assigning one input 5 to 2 outputs. This is not a function. Answer is option number 3. Okay, let's just do number 4 just to illustrate, show you that this is the answer. So in this case, we have 3 goes to 6, 5 goes to 6, 7 goes to 6. We have repetitions in the y's, but does that matter? The answer is no. We are focusing on our x's. There are no repetitions, so that's why this is a function, but that's not what we're looking for. The answer is option number 3. All right, let's take a look at number 5. It says, in the diagram below, the spinner is divided into 8 equal regions. Which expression represents the probability of the spinner landing on B exactly 3 times in 5 spins? Okay, so this is a binomial probability problem. So in this problem, you want to make use of the formula and choose R, probability of success, times probability of failure, which is 1 minus P raised to the n minus R. Okay, now this is a difficult formula to remember for some of us. So what you want to do is you want to use your options to guide your selection. Okay, so n choose R basically means that out of n elements, you're choosing R. Okay, so let's read the problem. It says, in the diagram below, the spinner is divided into 8 equal regions. So we have 8 equal regions. Which expression represents the probability of the spinner landing on B exactly 3 times in 5 spins? Okay, so here, what's happening is, it's very easy to confuse your variables. Okay, so in this case, n is the number of trials, R is the number of successes. How many tries were there? There were 5 spins, And how many successes do you want? 3, to get B exactly 3 times. Okay, so in this case, N is equal to 5, and R, number of times you want to be successful, is 3. Okay, so in your setup, you have 5 out of 5 tries, choose 3. How many combinations of 3 successes out of 5 can you have? So just with this setup, guess what? You have eliminated options 1 and 2. Okay, so remember, the N is R represents number of trials and R is number of successes. Now we have 8 in this nice little spinner here. What role does that play? It helps us to calculate the probability of success. Okay, so if you want to get B, there's only one B here. How many possible spots are there? There are 8. So probability of success P is going to be 1 B out of how many? A total of 8. How many times do you want to be successful? 3 times. So out of 1 over 8, probability of getting exactly a B, out of the 8 different regions, is 1 out of 8 raised to the 3rd power. You can automatically see your answer is option number 4. Okay, the other portion is probability of failure. Okay, you fail if you get something that's not B. How many regions are not B? 7, because they're a total of 8. So you have 7 over 8, or you can subtract 1 from 1/8. If you spin 5 times and you're successful 3 times, how many times are you going to be unsuccessful? 2. Okay, so that's why your answer is option number 4. All right, sorry for the interruption. We're going to have to take a break here. So we're going to be uploading the remainders in the next clip. So if you found the contents of this tutorial beneficial to you, do give us a thumbs up. And if you want to gain access to the next clip, just click on the link provided below and you can get the remainder. And don't forget to subscribe so you can get updates to the remainder of this review series. Questions, don't forget, you can include it in the comment section below and we'll be glad to support you. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.